Now, wave motion on the topic of speed of sound. Speed of sound. According to Newton's formula, according to Newton's formula, speed of sound v is equal to root of p by rho. That is due to, we know, speed of sound is longitudinal waves which requires material medium for the propagation. That's why a good medium should possess elastic nature, good medium should possess the properties of elastic nature as well as inertia. So, depending upon these properties, we can write speed of sound. It can be v is equal to e by rho, where e is nothing but a modulus of elasticity, modulus of elasticity. That can be written as either Young's modulus or bulk modulus. In the first year, we are go through the mechanical properties of solids. In the mechanical properties of solids, we know Young's modulus as well as bulk modulus. Okay, Young's modulus y is equal to f by a by delta L by L, that equal to f by a into delta L. Then what about bulk modulus? Bulk modulus can be written as hydrostatic pressure by strain, volume strain. So that is equal to, it can be written as dP by minus dV by V. So these types of terms are used there instead of speed of sound. Of course, at NTP conditions, by calculating the speed according to Newton's formula, that is about 280 meter per second approximately. 280 meter per second, which is not correct. Why? Because of now that is the value is up to v is equal to 332 meter per second. So this is the correct value, but using this formula, we are obtaining 280 meter per second. So that is corrected by the Laplace. So which is so called as a Laplace correction for Newton's formula. Laplace correction for Newton's formula. That is v is equal to root of gamma p by rho, where gamma is equal to Cp by Cv. So that using this formula, then we are obtaining at NTP conditions, v is equal to 332 meter per second. Why this type of error occurs means, as temperature increases, speed of sound increased by 0.61 meter per second per 1 degree centigrade. So we know in earlier days room temperature is 20 degrees Celsius, but now what about the room temperature? It may be considered 28 or 30, but in some cities we may find in summer season 48 to 50 degrees Celsius also. So for 1 degree centigrade temperature, the speed of sound was increased by 0.61 meter per second. So that is the Laplace correction will be given as v is equal to root of gamma b by rho according to thermodynamics. Of course, thermodynamics, that is adiabatic process. We can get gamma is equal to Cp by Cv. Okay. Now v is equal to root of gamma p by rho. V is equal to root of gamma P by rho. But if we are using the ideal gas equation, according to ideal gas equation, for 1 mole gas, PV is equal to RT, that implies P is equal to RT by V. Now, it is volume. This is volume, okay? Volume. This is volume. This is speed. Speed V is equal to root of gamma RT by rho V, that equal to root of gamma RT by capital M. Why? Because of density rho is equal to mass by volume is the expression is used here. So mass is equal to density to volume. So finally expression of speed of sound V is equal to root of gamma RT by M. V is equal to root of gamma RT by M. Okay. So we have the expression V is equal to root of gamma RT by M. Root of gamma RT by M. Okay. Now for given gas, molecular weight is constant. For given gas, gamma as well as molecular weight is constant. Hence, speed is directly proportional to absolute scale of temperature. That is the T Kelvin. Now, V1 by V2 is equal to root of T1 by T2. V1 by V2 is equal to root of T1 by T2. Now, as this absolute scale of temperature, that can be written as say T plus 273 degrees Celsius. T plus 273 degrees Celsius. T Kelvin is equal to absolute scale of T Kelvin is equal to T plus 273. That implies V1 by V2 is equal to root of T1 plus 273 by T2 plus 273. T2 plus T73. Let us consider T1 at 0 degrees Celsius. T1 is equal to 0 degrees Celsius. Then V1 is equal to V0. Now at T degrees Celsius, T2 is equal to T degrees Celsius. V2 is equal to Vt. Vt is equal to Vt. So that V1 by V2 is equal to root of T1 0 plus 273 by T2 plus 273. Now V1 by V2 is equal to root of 273 by T2 plus 273. That implies V2 by V1 is equal to T2 plus 273 by 273. Here I am taking reciprocal. Denominator is taken out as numerator, hence both sides I am doing like that. That implies now V2 by V1 is equal to root of 273 by 273 plus T2 by 273. T2 by 273. Now it can written as V2 by V1 is equal to root of 1 plus T2 by 273. T2 by 273, or simply say T. Simply T, of course. 0 is substituted here now. Okay? T. Let us then consider it as a T. Now V2 by V1 is equal to 1 plus 2 by 273 whole power 1 by 2. Why I am discussing all these things? Because of we have velocity of sound using resonance column apertures. Velocity of sound, we have to determine velocity of sound. At that particular situation, we have to find the speed at T degrees Celsius or speed at 0 degrees Celsius or velocity of sound at 0 degrees Celsius. For that purpose, I am doing here like this. Okay. So here we have to do the small changes. That is nothing but say here this is V0, this is V0, this is Vt. Okay. V0, Vt, Vt, V0, Vt. Here it is Vt. This is V0. Vt, V0, Vt, V naught. Now apply binomial theorem. Apply binomial theorem. That is, if we have the function 1 plus x whole power n, if x is very very less than 1 anukunte, then 1 plus x is equal to, it can be written as 1 plus n x plus and so on, but remaining terms will be neglected. Like that, here we have to apply that power 1 by 2 can be written as here Vt by V naught. Vt by V naught is equal to 1 plus 1 by 2 into 1 plus 1 by 2 into t by 273. T by 273. So Vt by V naught is equal to 1 plus, of course, Vt. Vt is equal to V naught into 1 plus t by 546. 1 plus t by 546. Okay. Now Vt is equal to V naught into 1 plus 1 by 546 can be written as 0.61 t meter per second. 0.61 t meter per second when it is multiplied. When it is multiplied with V naught. When it is multiplied with V naught, t by 546. Now it can be written as V naught plus V naught into 0.61. After multiplying that, we can get 0.61 meter per second into t. 0.61 into t meter per second. 0.61 into t meter per second will be the expression for speed of sound at t degrees Celsius. So that's why the value which is get here 0.61 for 1 degree Celsius, that indicates for 1 degree Celsius rise in temperature 0.61 meter per second speed will be increases. 0.61 meter per second speed will be increases. So see here. So V is equal to root of gamma RT by M is the expression. Let us consider for same gas, only the changes occurs in temperature and speed. That's why we have to take gamma R by M is as constant. So V is directly proportional to root T. V is directly proportional to root T, and develop that is as V1 by V2 is equal to root of T1 by T2. So given V1 is equal to V, initial velocity is V at 0 degrees Celsius. To double the speed, what will be the temperature? So that V2 is equal to V, that is given data. So we have to find T2. So that after substituting we will get the formula like this. Then squaring on both sides. We get this expression. Both sides getting squared. So root square gets cancelled. So then 273 by T2 we can obtain. That is 1 by 4. So T2 is equal to 273 into 4. And finally T2 is equal to 1092. To convert it into, this is the absolute scale of temperature. If we want to convert into Celsius scale, we have to subtract the 273. Okay. And finally we will get the answer 819 degrees Celsius. So here is the similar model as the previous problem. Here we have the speed of sound in air at 15 degrees Celsius. Speed of sound in air is at 15 degrees Celsius is 340 meter per second. V1 is given. The speed of sound in air at 30 degrees Celsius. Speed of sound in air at 30 degrees Celsius. T2 is given, and 75 centimeter of mercury will be in meter per second. We know that speed of sound depends on molecular weight or absolute scale of temperature. That is V is equal to root of gamma RT by M. So we have to take the relation between speed and temperature as speed and molecular weight. Here we are not provided with the different gases. So that relation will be taken as say V is directly proportional to root T. In case of different gases given, we have to take the molecular weight. Okay, so V is directly proportional to root T. Now V1 by V2 is equal to root of T1 by T2. But now here we have T1 is equal to 15 degrees Celsius. Then capital T1 is equal to 15 plus 273. That is equal to 288 Kelvin. At that particular situation, V1 is equal to 340 meter per second is given. 340 meter per second. Now, as temperature is given as say T2 is equal to 30 degrees Celsius. Then what about the absolute scale of temperature? We have to add 273 to convert Celsius into Kelvin. So that is equal to 303. Okay, 303 Kelvin. 303 Kelvin. And here V2 we have to find. Okay, V2 we have to find. By substituting, we will get 340 by V2 is equal to root of T1 by T2. 288 by 303. That implies V2 is equal to 340 into root of 303 by 288. So that is F. That is in the options. 303 by 288. No need to calculate it. Okay, now here we have a relation between speed of sound and RMS speed is there now. Relation between speed of sound. So let us consider speed of sound is as a V. RMS speed can be represented as say VRMS. So just now we go through the Newton Laplace equation. According to Newton Laplace equation, V is equal to root of gamma RT by M. V is equal to root of gamma RT by M. But you know, according to kinetic theory of gases, last year 14th chapter, first year 14th chapter, that is VRMS is equal to root of 3RT by M. Now, say expression number 1. This is expression number 2. Now 1 by 2 implies V by VRMS is equal to root of gamma RT by M by root of 3RT by M. That is equal to root of gamma by 3. That is V by VRMS is equal to gamma by 3 whole power 1 by 2. Gamma value is constant for given gases. So if it is for monoatomic gas, gamma monoatomic gas 5 by 3. For gamma diatomic gas 7 by 5. So if nitrogen gas is provided, then we have to take 7 by 5. If it is helium gas is provided, gamma will take let's say 5 by 3. So that V is equal to some, of course it is a constant, some constant into VRMS. So V is proportional to VRMS. So we can draw the graph by taking VRMS values on x-axis, speed of sound values are taken on y-axis. We can obtain straight line from the origin. That is particularly, of course. So V by VRMS is equal to constant. V equal to VRMS. V proportional to VRMS. Now here we have the problem. The ratio of velocity of sound in hydrogen and oxygen gas at STP is. At STP conditions, we have to find the ratio of velocities. Means taking temperature is constant. Why? Because of ratio of velocities we have to find at two different gases. So V is equal to root of gamma RT by M. So for same gas, for different gases at the same temperature, so V proportional to root of gamma by M. V proportional to root of gamma by M we have to take. But in case of kinetic theory of gases, we are writing simply V is inversely proportional to square root of a molecular weight. But here, for different gases, of course, here we have hydrogen gas. It is diatomic. Oxygen gas, it is diatomic. Then there is no problem. No need to take gamma. Why? Because of for both of them, gamma is equal to 7 by 5 we have to take. Gamma value 7 by 5. So that V is proportional to root M. Okay. For example, if it is helium, here is oxygen is given. Helium is the monatomic. Then values will be changes. Okay? Keep it in your mind. VH by VO. If the gases names are given means you have to take the notation like this. Don't take the notation as V1, V2. Don't take the notation as V1, V2. Maybe some situations in tension we may mismatch the given values. Then what happens? Problem will be getting wrong. So always keep it in your mind. If for different gases you have to write notation as the H as well as O or something like given gases. Okay. Now root of inversely proportional. We have to write MO by MH. That is equal to root of molecular weight of oxygen is 16. As it is diatomic, we have to write 16 into 2. Molecular weight of hydrogen 1. As it is diatomic, we have to write 2. So that is equal to root of 16 by 1. Answer will be 4:1. So VH is to VO is equal to 4:1 ratio. So speed ratio is 4:1. Speed ratio is 4:1. Now here, as earlier we were discussed that is RMS velocity and speed of sound denotes as, say let us consider this is V, this is VRMS. As earlier we were discussed, V by VRMS is equal to gamma by 3 root of. Yes or no? So substitute them. C naught by C is equal to root of gamma by 3. That implies C naught is equal to C into root of gamma by 3, or C naught is equal to gamma by 3 whole power 1 by 2 into C. This is the option given in the multiple choice. So we have to choose the answer. C naught is equal to gamma by 3 whole power 1 by 2 into C. The velocity of sound is Vs in air. If the density of air increases to 4 times, then the new velocity of the sound will be. We know V is equal to root of gamma P by rho or root of gamma RT by M. Now here we have the relation, with the density. So here we have the density is increases to 4 times. Density increases 4 times. So take the relation V is inversely proportional to rho as pressure is given as a constant, So Vs by V is equal to rho by rho s. If the density of the air increases to 4 times, so as Vs at Vs, so that rho s is equal to rho, or else I will write like this. Okay, just write for my convenience. I will write like this. Say V1 by V2. V1 by V2 is equal to rho 2 by rho 1. Root kada? Rho 2 by rho 1. So V1 is equal to Vs, V2 is equal to V. Rho 1 is equal to rho 2 is equal to 4 rho. Now Vs by V is equal to 4 rho by rho, root of Vs by V is equal to root 4, that is equal to 2. That implies speed V is equal to Vs by 2. In AP, wave motion is the chapter in second year compared with the NCERT syllabus that is in first year. So we have 30% of direction or deleted topics for IPE only, but not for NEET and JEE means. Second year students, now be aware of that. For 2021, for the academic year of 2021, we have to prepare wave motion for JEE mains as well as NEET. But some part is deleted for IPE only, Intermediate Public Examination. Okay. For more videos, you have to subscribe this channel, ANIL'S Advaita. So it must be gainful to you. Thank you.